Hello everyone, hope you all are doing good. Welcome to yet another episode of Azure Happy Hours. This is Parth here from Reactor Bengaluru. I am the event and program manager for Reactor and would like to bring in Reshmi. But before, let's go through our code of conduct. We are all here to participate together, learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in a way do we all engage. Yes, we do encourage you all to participate and please do drop in all your questions in the chat section. And now would like to bring in Reshmi, the host of our happy hours. Hi Reshmi, how are you doing?
Hi, Pat. Good evening. How are you?
I'm
Long
good.
time.
I long time and today's band I feel like lockdown times. Like from morning to evening we are at the home.
Tell me about it. Yeah, tell me about it. Like everything that you have to do is staying within the four walls. I'm just dealing with it,
Yep.
but I can't wait for 7:30 to kick in. 7:30 p.m. Here we go.
Yeah. Yeah. And
But
two
yeah,
we
very
have a
excited.
long weekend as well. Yep. Yep.
Yes, yes. But more than that, I'm very excited for today's session because I think this is one of the sessions where people have been rooting for part two. So I'm really happy that the part two has finally happened. So I think without further ado, we should definitely welcome the speaker for today. So
Yep.
Jayesh, please join us.
Hello, good evening.
Hi
Good
Jayesh, how are you?
evening.
How's it going?
Doing really great here. Like really nice to meet you again. Like
Yeah.
I'm mostly just home myself, so nice to see you, Vivek, as well. Great here.
Oh, yes. Vivek is there cheering with all the comments with that. But yes,
Mhm.
thank you so much once again for joining us for the part two. And part, I think we are good to kick off here.
The floor is all yours.
Thank
Okay,
you.
perfect.
Thank you. Awesome. So, Jayesh, before we start off, right, I think you already have it as a part of your deck, but for the folks who haven't captured the previous session of yours, maybe we
Mhm.
can do a quick recap of who you are, what you do, what your interest lies in, and what did we talk about in the previous session. So,
Yeah, sure thing. So,
yeah.
before going to the slides, I'll just maybe do this short walkthrough. So, I am Jay Sharma. I work at this startup called ZenML, and we are an MLOps startup, and we help companies take their machine learning models into production using an open source library called ZenML. And in the previous iteration of this talk, what we did was we designed a Slack bot that could answer questions based on the documentation of any specific tool. So let's say I designed this bot which could answer questions based on ZenML, looking at all the pages that ZenML has on this stocks online. And we looked at how the
Mhm.
flow works, like how do you design chains, what are vector databases, how do you store those things. That was the previous iteration. In this iteration, we are going to make that bot a bit more powerful by allowing it to
Mhm.
give more than just question answering ability. It also has a personality now. It can answer questions about itself, like who it is and stuff like that. And it also has other abilities like maybe contacting somebody else in the team to forward requests to, like basically just supercharging the previous version of the bot. Like the previous one was just simple chain which answered questions. This one can have n number of possibilities depending on what your where creativity can take you.
That sounds really interesting. And just one quick question before we dive deep. Are you folks like actively using this?
Yeah, it's live on our Slack right now. So the agent is
Awesome,
not live.
awesome.
The previous version of the bot is live. This is something I'm still working on. So like the thing is
Uh-huh.
like it is a bit more powerful, so I have to do lot more testing on what
Mm,
exactly it behaves, how it exactly behaves, and then we'll launch this version. But a previous version of
yeah,
it is active right now. I can send you a link afterwards. Towards the end of the demo, I
awesome.
can put
Yeah,
that as well.
yeah, that sounds really interesting. I would definitely love to try it out. Cool.
Yeah,
So let's go deep into it. So we can start off with your presentation.
yeah, yeah.
But can we have the slides, please? Awesome.
All right. So really excited for this talk. I want this to be like a two-way street as well. So if there are any questions which comes up, I think probably if it's relevant, we can take it. Otherwise, we'll answer it towards the end. Yeah, I already introduced myself. I work at ZenML. Apart from that, I do talks. I write blogs. Sometimes make videos as well. And I enjoy sports, primarily basketball and those things, and also like hiking in nature. That's some of the things which I do. And if you want to connect with me, you can find me at WJH on Twitter. I think that's where I'm the most active.
Hmm.
Today, what we'll cover is first of all introduction to what agents are, like intuitive understanding, just going through the flow of how they are. The second would be how you implement those using this library called LangChain. You can also choose to implement it otherwise, but we'll just go through the LangChain version of it. Then we'll talk about challenges in production. And by production, I mean when you try to actually put it into use, like on your own documentation page, on your own Slack or some other place. That is what I mean by production. We'll see what the challenges that are coming into the question when you actually develop these things. The fourth would be how would you actually build this solution, looking at all the challenges. What is the solution on how to build a production ready environment using XML and Azure OpenAI? And the last
Mhm.
would be a demo where I just walk you through these code and then also look at this question answer. We'll ask some questions to the agent and see how it answers.
Yeah.
Okay, so yeah, let's head on to the AI agents thing. So what exactly is an agent? So I already gave a brief idea towards the start, but I'll just
Mhm.
maybe more concrete terms here. So far what we have had is LLMs. You all know about GPT, ChatGPT models, and those models can help you construct answers predicting the next word. That's what LLMs are. They're very good at natural language understanding. They can understand what the user writes, and they can also generate output based on that. Now, if you could give those LLMs a way to act on these as well. So let's say if I ask an LLM about, let's say, show me the top 5 hotels in Goa or some other place, and then it does know about those places. Maybe it can do a search and other things and figure out a list of it, but it can't really do an action on it. It can't really book the one. So if you gave the agents if you gave the model the ability to act on these things, like call APIs on your behalf, call functions on your behalf, that is what we call an agent. So an agent is just an
Mhm.
LLM which has access to a set of tools, basically. But how do you, like, now the question is very simple, like how do you make this LLM aware of these tools in the first place? Like you can't, like how do you do it? Like what is the interface? So the
Mhm.
answer is pretty simple. Like no guesses there. You can just tell it because it's a language model. So the way you communicate with these models is through English language. You don't have to write code. You don't have to write functions to actually communicate with the model. All you do is just tell the model. So you give a prompt to the model which says, let's say this is the LLM, for example. You can tell that LLM that okay, you have access to this API. And how do you tell what the API does? You have to maybe pass in two different prompts. Let's say this API, like for example, the Blinkit API, I can tell the LLM that the Blinkit API helps me order groceries online. So you're telling the LLM, okay, this is this thing, it does this stuff. And how to
Mhm.
use it also is something you can have to tell the LLM. So you can tell that we have access to the Blinkit function, but to use the Blinkit function, you have to set these inputs. You have to set the ingredients, you have to set the address, you have to set the payment option, for example. So you give the LLM details about the function on how and how to use it and when to use it. So you just send that as a prompt to the model. And once that is there, the model can then start to worry about, like, they start to decide what to use when you ask a question. So in more programmatic terms, there are three different parts here. The first is LLM model, which you're all familiar with. The second is a set of APIs, which is the tools that it can have access to. And the third one is an orchestrator. Now, why is an orchestrator important? Because let's say the LLM itself can't really go and call the API, right? Even if I tell the LLM, okay, you have access to the Blinkit API, and then you have to like call this API when you want to, but it can't really go and make the call for you. Can't really create a HTTP request for you, right? So that's where the orchestrator comes in. The orchestrator links the model and the API. So it
Mhm.
takes the it takes the output from the LLM. Let's say the LLM tells me that okay, call this API for me with these inputs. Then the orchestrator's job is to take these inputs, take the function name, and then call that function with a certain set of inputs. And then the
Mhm.
output of those APIs would also be put back into the LLM model. So this orchestration work is handled by an orchestrator. That is what it is. So broadly, this is how it looks like. You have an LM, you have an APIs, which are your functions, and then you have some kind of orchestrator in the middle, which is coordinating efforts between these two. And that's the whole high level workflow, right? And like so far, if there's any questions, I'll be able to take them. But I think this was much simple in terms of the flow as well.
Yeah, I think we just had one question come up. So Wesley has asked if this is the same as the semantic kernel.
Uh, Maybe not. Like I maybe touched on that earlier. I'm not really familiar with the exact specifics of that. So maybe
Mm-hmm.
we can talk that later on as well. But I'm not really sure
Okay.
if there's any similarities. Feel free to derive them. But like I don't know
Okay.
if there's any sure linkage between these terms. I have no really idea, not good idea of that.
No worries.
Okay.
Yeah, I
So
think we can continue.
yeah, I think so. So far, the flow is like this. You have the LLMs, APIs, and the orchestrator. Now, when you start coding it, like when you start putting it into code, you can use like different abstractions. You can use your own like code. You can design your own classes and do stuff like that. But there's also this library called LangChain, which people might be familiar with. And what LangChain does is it offers you a framework which has many of these classes already implemented. So let's say if you're
Mm-hmm.
looking at an orchestrator, you're looking at LLMs. So there are abstractions for these concepts which are already present in LangChain. There are also implementations of these abstractions. And what I mean by
Mm-hmm.
that is like this flow, like the communication between LLMs and the all of that does not have to be done manually by you. You don't really have to take the outputs yourself and then call the APIs. You can use abstractions for them. And these are the abstractions that LangChain offers. So for LLM models, there's this class called agent in LangChain, which you can use as a wrapper around the LLM model. For APIs, you have these tools which you can define. Like each tool has already a description and like when to use them. All of these are just parameters of the tool class. And then this is like something we'll also look at when we look at the code. But right now, it's just the same thing. The third is an orchestrator, which is the thing we talk about, which orchestrates these actions, and that is called an agent executor in LangChain. So basically, all of these concepts have an implementation that you can just use out of the box with LangChain, and we'll look at that later on. But okay, like once the basics are clear, once you know how to implement these, like let's just focus on the problem at hand. We want to design a bot which can answer questions to you. Like, what does it entail? So it entails that the bot needs to understand human language, because you can't really have like specifics. People can ask all sorts of questions, casual, professional. So it needs to understand human language, of course. It needs to be backed by large amounts of data, because you have, let's say, pages and pages of documentation. You have maybe past Slack threads. You have other sources of information which needs to be retrieved by this bot to be able to answer specific questions. And then once you have retrieved all of these relevant chunks of data, you also need to construct them in a human-friendly format. Again, so all of these needs to be responsibilities of an agent which can answer questions to you. And so how do you build such an agent, right? So how do you have the access to such amounts of data, and then how can the agent use it? So that, like, what is the idea behind it? So it's pretty simple. As you said, like an agent has access to tools. It's an LLM itself, but it has access to some tools. So what we do in this scenario is we give it a tool that can have this huge knowledge of all the data which relates to your specific, let's say, tool. For example, let's say in the case of ZenML, what I can do is I can give it access to a vector database that hosts all of the information which is sourced from the documentation of ZenML. So now I tell the agent, okay, you have access to this vector store. And if anybody asks you a question about, let's say, ZenML, about whatever this thing, you can use this tool to answer those questions. That is what I'm doing here. So instead of the Blinkit example, what we're doing is we're just giving it a ZenML example. We're just telling it, okay, this is the vector database. It has all the information you need. Anybody comes up with a question like this, just use that. That is the idea, right? So that is how we enable such a agent.
Yeah, Jayesh, I have just one very fundamental question over here. So, how frequently are we talking about refreshing the database, or how frequently are we like training the agent and the model to keep working, improving on the solutions? Because it's not only like very costly, I would assume, but also we need to make sure that it is up to date, right? So, how does
Yes.
that work?
Yeah, that's a good question. So what we do usually is like generally, if every new release you have to make a new vector database. For example, let's say with version point, like we are on 0.44.2. So let's say when a new
Mm-hmm.
version comes up, I have to again update the vector database to point to the new version, because I don't want people to
Mm-hmm.
be using an older data, like something like that. So you can set it up as a trigger. So like when we come to the production side of things, like when I show you how the production like pipeline works, that is where all of these issues come into play, because you have to set up like, until now all is fun and games because you're just practicing it on your local machine, but all of those questions you're asking are relating to the production, and that is where a pipeline example comes in. You can set up triggers for it, you can set up when to trigger it, how to trigger it. All of these things come into the picture afterwards. But like we'll take a look at it, and I'll come back to the question. Thankfully
Yeah,
maybe answer.
yeah, awesome. Awesome. Yeah, I we do have one more question in the chat. Do you want to pick it up now?
I go.
Yeah,
What's
sure.
the role?
So, yeah, it's Ravindran asking how to handle data privacy like credit card info.
Credit card info. I'm not sure like where that figures in, but if you're asking about, let's say, like a bot which can answer questions but requires access to your information, in that case, like we'll be touching upon that topic as well, like going forward,
I'm
like how
assuming
to.
it's regarding like storing it around, possibly. Like we're
Yeah,
talking
but
about
that,
like
yeah.
fetching data from. Yeah.
But that depends on exactly on how you implement it. Like there's this load of, I don't have a specific answer to that, because
Mm-hmm.
if you choose to use a model which is, let's say, open source and running on your own system, then all the
Mm-hmm.
data which goes into this model is also part of your infra, so it never leaves your system. But if you're using a third party provider to then and you're sending your information to that, for example, this third party LLM application, then of course it's not under your control. And like it then depends on the policies. For example, you can look up the privacy policies for OpenAI, and I think that has the most advanced one among all of the like Anthropic and other things. So like usually OpenAI is the most safest one if you want to send
Mm-hmm.
information, but like that's out of the scope for now.
Yeah, yeah, yeah.
Okay,
Makes sense.
so yeah,
Cool.
so
Let's
coming
go
back to
ahead.
this, yeah, coming back to this, I think So far we understood the idea. We have an agent, we just give it the vector database, which has all the information about ZML, and then we tell it, okay, if somebody asks a question about ZML, just use this to answer. Basically, that is it. Now, what is this vector database that I'm talking about all the time? Now, this is this is the walkthrough of the process that goes behind enabling an agent to answer questions, right? So what you do is you first store all of the data as vectors. So what you do is you take up documentation, you take up Slack threads, everything, and then you make vectors out of this data. This is how you store it in a vector database. For example, it could be Chroma, it could be Weird. There are hundreds of new startups which are coming up with their own databases. You can use any of them. And then the idea is very simple. Whenever a question is asked, you use similarity searching to figure out what are the most relevant chunks of this data. And then you bring those chunks in, and along with the question, you pass to the LLM. So you tell the LLM, okay, this is the question, and this is the context that you have. Now answer this question, basically. So this is what an artificial diagram of that looks like. So it's much easier to understand this way. So what you do is you first prepare this vector store. And this vector store is prepared separately by all of the data which you have. It could be from anywhere. Hundreds of sources populate the vector database. And when a question comes in, you use similarity search to figure out only the relevant chunks of it. Let's say if you have thousands and thousands of pages, you only have like maybe one page which relates to your question. So figure out the relevant chunk and then pass on the question and the chunks to the LLM and get an answer back in a natural language. That is the idea behind the vector database story entirely. So what we are doing now is we are giving this capability to this agent as a tool. We're telling this agent, okay, you have access to this stuff, use it whenever you want, basically.
Got it.
So that's it. Like, I think we figured out how it works because you have an agent, you have a tool, and like you tell the agent, okay, use this tool whenever the question comes up and you're done, right? So unfortunately, that's not all. Like it's so far, it's good enough for you to test it on your local machine, run it, and it would work perfectly. So it's not a problem at all. But since Reshmi also asked questions about like what happens when a new version comes out, how often do you update it? So all of these things would mean you need more than just a simple notebook or a simple script that does it, because you don't have to manually run every time a new version comes out. Right? That's a lot of trouble, and also have to manage and track versions. So that's much harder to do it in a manual format. So what we do is now we talk about challenges in production. So we'll first cover these challenges, then I'll talk about what the solution to this challenge could be. So as I said, like there could be multiple sources of data which are like constantly sending data to this repo that we have. For example, you have new pages of documentation, you have new threads which are coming into Slack every day, so new context emerging every day, and then you have to populate that in a database in some format. So ideally, you would need something like an automation that can help you do all of that instead of manually having to run it every time or every other week. So that is one of the challenges you need to have, figuring out how to automate this process. The second would be tracking code changes to the logic. For example, let's say I am creating, like there are hundreds of options. As I said, like you have many vector databases you can choose from. You have many parameters you can set for the vector databases. So let's say over the course of time, let's say today I designed a database in one format, but tomorrow I want maybe some other changes to come into picture. So how do you track the code changes to this logic that you're building? Because maybe what I would realize down the line, okay, maybe the one which I hacked on the last weekend was the best one. So maybe I want to go back to that one. So how do I do it now? It's all lost. So you need to wait to track the code changes, you need to version the vector database which are created. For example, let's say I can show you an example of that when you get to the code side of things. So let's say you're developing multiple iterations of this thing. For example, this agent has a specific personality, but now I think this personality is not good enough. It's being more hostile to the users. So maybe I want to change the personality of the agent, but retain the other capabilities. So I'm using a new version of the agent now. And maybe I want to go back to an older version at some other point in time. So like, there are many things which happen when you talk about production cases. So all of these need to be tracked and mentioned as well. And like as somebody rightly pointed out, there are also concerns about leakage of data through proprietary LLMs, right? So that is something which I think one of those guys asked. So what happens if somebody gives like really sensitive information to the LLM? Where does it go? How is it handled? So all of those are challenges which come into production, come into picture when we talk about production and other things, right? So what is the solution to that? ZenML is one of the frameworks you can use. Like that helps you productionize this entire LangChain pipeline. So far what you've seen is basically simple logic which helps you create agents. I'll show you that in the code. But what ZenML does is in very simple steps, it allows you to write pipelines in pure Python. So you just don't have to write YAML files, you don't have to write different configurations. You can just very naturally, as you write your own machine learning scripts, you can just use that and just add annotations where you want to. And from day zero, you can be production ready. So your pipeline, when you write it with ZenML, can be run in cloud or any other environment right from day zero. You don't have to worry about like creating Docker images and stuff like that as well. Tracking versioning of artifacts is done by default. So every step, the output of every step is automatically tracked and versioned in your artifact store. All steps are cached. If you want them to, for example, if you want to run a pipeline again, you don't want to run every step which is not being changed at all. So you can just use the cached version of those steps and only run the steps which are really relevant. And you can then see logs, visualization of your outputs to the ZenML dashboard. So This is just a subset of the features that ZML offers. There's much more, but I think it's the most relevant to our use case here. So what I would imagine is that a pipeline to continuously keep the database updated would look like this. So you need to have, let's say, URL scraper that scrapes all the documentation URLs. So let's say if your base URL is docs.znml.io, this thing will generate all the additional pages like slash orchestrator, slash this and that. So this is going to give you a list of all URLs. The second step would be loading them into documents. So like getting out the data of all of these different URLs. Then you create the index using whatever vector database you want. It could be Chrome, it could be Files or some other database. And once you have the database ready, then you can create an agent based on this database. So basically, the create agent step is just taking the database and then putting it into the agent, telling the agent, okay, this is the new database, take this one, basically. And the last step is, of course, deployment. That is what a pipeline would look like. So you can just trigger this pipeline whenever a new version comes up. You can set up automatic triggers as well. Let's say a new version comes up, just trigger this entire thing again. So let's say maybe the URLs didn't change, so the first step would be cached, something like that. So you don't really have to worry about all the steps running again. Automatically is taken care of mostly, all of these things.
So for
So that
the end-to-end flow over here, like, is there an average time period that we can expect this would take, or it also depends on the kind of data that we're working on?
yeah, it definitely depends on the data you're kind of working on, because let's say if you have a larger number of URLs and if each of the URL has loads and loads of data, then the first two steps are going to take a lot of time. But like if usually you use like XML by default, there's caching enabled. So for example, let's say if you feel that the URLs haven't changed, the data hasn't changed, then the first two steps are always cached. For example, let's say I only want to change the logic in the index generator. Maybe I want to use a different vector store and not use the one which I'm using currently. If I run the pipeline again, the first two steps are just skipped. You just take in the outputs from the versioned artifact store. It will use the latest version, and you go ahead with the next steps. So it definitely depends on the kind of data used. For example, with our use case, we don't have a lot of data here. It takes around maybe 15 minutes to run or 20 minutes to run on a local machine. If I run it somewhere else, it might be a bit faster, but on my machine, it takes around 15 20 minutes to complete the pipeline.
Makes sense, yeah.
Yeah, but it
That's
depends
a
on how
good
much.
enough average time.
Yeah, good enough average. You can use maybe a higher compute, like some online computes you can use, and then maybe it might be a bit faster. Like that depends on what stack you use. But that's the flexibility of ZML. If you have a pipeline built once, you can run it anywhere, basically just changing the stack. So write once anywhere kind of behavior, basically. Okay, so far we've talked about let's say the entire flow, productionizing the pipeline, but a really important part of it is also choosing the LLM, because LLM is what powers your answers, it powers what you need. And if you're concerned about, let's say, your data leaving your premises and going somewhere else, in production you should probably be using Azure OpenAI then. Because let's say even if you're in your prototyping or building a POC, you might use an open source model to save on cost. That won't give you really nice results, but it might at least help you validate your flow. You can also use OpenAI's APIs as well. It's relatively cheap, not too expensive. But if you have access to Azure OpenAI, then that's the best option if you use in production. Because in that case, what happens is you can create your own models there. So you have this kind of a studio. You can create your own deployment there of whatever model you want, GPT-4 or any other code models that you want. And then you can use those in your application as an endpoint. So it has the same spec as an OpenAI spec, and then you can use that in your existing applications. It doesn't really change too much. And what the benefit with that is that the data doesn't leave your premise. It doesn't leave your tenant. It just stays within that and doesn't go to OpenAI or any other third-party providers. That's at least peace of mind, whatever that is. Yeah. So that is the idea. And so far what we've done is we've completed the cycle of understanding what we need. So we have understood what a primal POC might look like, which is just involving LangChain, developing an agent executor, developing this thing, which should work very fine. Then we looked at some challenges with production, which involves like versioning, tracking, automation, using the right amount of, using the right LLM for your security and stuff. So that completes the whole picture. Now what I'd like to do is I'd like to jump into code, because I think that's the most interesting.
I think before that, Jayesh, we do have a good number of questions from the first part of the discussion. Yeah,
let's take it.
Cool. So starting off with Priyadat's question was, how many previous versions do you feed in the vector store?
How many previous versions do I feed in the vector store? So what I do right now is like the current implementation that we have on the Slack that uses only one version. So that is always the latest version by default. It overwrites whenever a new version comes out and I run the pipeline. It just takes in the latest one and then uses that because it doesn't have the flow. But with the agent that I'm developing right now, what you can do is you can essentially have many different tools, and each of these tools can correspond to different versions. That's the idea. So at a point, a vector store collection can only have definitely one set of versions, because it wouldn't make sense to
Mm.
have one collection have many other,
Searching to,
because it would be
yeah,
conflicting details between different versions, right? For example, let's say
yeah.
if one of the features get removed in a new version, that won't work. So you definitely need different collections. And by collection, I just mean a set. It's like a logical grouping of your vectors. That's what a collection is. It might have different names in different vector stores, but I think collection is the most commonly used word. So
Yeah,
yeah,
yeah.
you can't really have in one collection n number of versions. You can have n versions in n different collections, and then you can make the LLM choose between these versions. I'll show you how it looks like in the code. Maybe
Hmm.
next question.
Okay. Awesome. Cool. The next one is by Joe. I think Vivek has already answered in the chat, but let's just quickly bring it up on the screen as well. Can we connect Azure Cognitive Search with LangChain as vector database?
LangChain is a vector database. I'm not sure what that means. Like LangChain is a
So,
yeah.
yeah, continue. Sorry.
Yeah, it's more like a framework, so it's not a vector database in itself. But I'm pretty sure you can do everything with Azure, so there's a lot of flexibility there. So I
Yeah,
think
I
you
mean, Vivek
this
has
guy.
guaranteed that you can. So I want
Yeah,
to say that yes, it works.
yeah, I can say the same. I think it's a bit mis like malformed question, but I think whatever is trying to get to, I think you can do that probably. And if not, you can just
Yeah,
reach out to
yeah.
me afterwards. I can help you set it up.
Yeah, yeah. Vivek's expertise is going to help us there. And
Yeah.
now, going lower, I think Jishnu has asked a question during the agent discussion,
Mhm.
asking if these blocks are individual microservices.
These blogs, I think he means maybe these ones. These are not
No, no, no.
microservices. Okay.
I don't think we were on this slide at that time. I think it was later when we were looking into, no, even later.
Oh, these ones, I think, the
Yes,
architecture.
the
Yeah,
pipeline
yeah,
architecture.
these are
Yes.
not microservices. You can, like, these are just different Python functions which are run on different environments. So when we look at the code, pretty much more clearer. So you have different Python functions which are defined in a pipeline as multiple steps. And with Xamarin, you can
Mhm.
define where each step runs. So basically, you can choose one step to be run on some high computer environment, the other step could run locally. So all of those is flexible, but essentially they're just Python functions. And these are run as separate processes. For example, maybe in different Docker containers. For example, if you have, let's say, a Kubernetes orchestrator set up as your ZML orchestrator, then if you run this pipeline, each of these blocks would be run in a separate pod, basically. That is what it is. Separate processes run in different isolated container environments, basically. That is the idea.
Hmm. Okay, got it. Cool. There are a couple more questions. Would you like to take it now, or should we do the demo first?
Maybe, yeah, maybe let's go to the demo first,
Yeah,
and then I'm
yeah,
sure there'll be more
yeah. Let's
questions.
go. Yeah.
Okay, so all right, perfect. So let me start off with a very simple idea first. So we already looked at the pipeline. We have looked at the different blocks right now. And this is how you define that pipeline in Xamarin. So it's pretty simple. For people familiar with Python, it's just the same thing. You just define a function here. Let's say define docs to agent pipeline. And then this pipeline can take in the definition, you can define how the different steps relate to each other. So I'm just defining randomly. Okay, the first step is an URL scraper, as I already showed you. It takes in the docs URL, all of these URLs it takes in as input. And this gives you the flexibility to change the URLs when you want. So for different tools, you can use different URLs basically. And then the output of this is fed into the next step. So how you do it is in XML, you link these steps either through the outputs or through dot after, dot before kind of notations. So here I'm doing a very simple data linkage. So the URLs from the first step would go into the next step, which is the URL loader, which loads documents.
Mhm.
Now the documents from the second step go into the third step, which is the index generator, and it just generates the index for you. And the last step is just taking the vector store and then generating an agent out of it. That is the idea, right? Now, the most relevant steps, which I think are the most interesting, are the index generator, first of all, because this is where I generate the vector store, which I was talking about earlier. So as you can see, I'm
Mhm.
using Fice, like that is a library from Facebook. But I can also choose, let's say, Chroma or Vivian, any other n number of libraries just to generate the documents. But the step still remains the same. So if you look at the pipeline definition would still remain the same. Having it as a different functions gives you the flexibility to swap out different functions when you need to. Let's say in the future I want to use a different set of this thing, I'll just add a new function. I'll just place a new function in that placeholder value, the index generator function. So that is how you easily switch between different implementations of the thing, but the pipeline remains the same. That is the idea. So it gives you a way to it makes it really modular as well. So you define the embeddings, you define character split, and then you just return the vector store from this library here. That is the idea. Now, the second most interesting step is the agent creator, of course, which is the highlight of the show. So what this step does is, again, a simple Python function, as I said. All that converts this into a XML step is this step decorator here, That's all it does. So when you just add the add step from ZenML, you import from ZenML this step decorator, and then you add this as a decorator on top of the function that you have. And what this decorator does, it allows ZenML to know, okay, this is one of the steps. So what that means is all of the outputs of this step needs to be materialized and stored somewhere and dragged for each version. And also allows you to set caching enable or false here. So like you can also enable cache or disable cache here. So for this particular step, I have disabled caching. But for all other steps, I have enabled them on the pipeline level. You can see enable cache is true for the whole pipeline, which means like whenever possible, this pipeline will try to skip steps which are not changing. But this specific agent, I really wanted to be not cached. I wanted to run every time just for the sake of demonstration. So that is the idea, and it allows you a lot of different kind of ways, like what materializer to use when you're outputting it, like how to save the agent executor. So this class will define how exactly the agent executor is saved and serialized, basically all of those things. So it gives you a lot of flexibility in terms of how you store your data, right? And then when you define it as a step, then ZenML takes care of all of these things by default. So what I'm doing now is this: I'm defining a tools. As I said, like LangChain has this tool class which helps you define this API that we were talking about earlier. So if you look into the vector store QA tool, you can see it's implementing from a base vector store tool, right? And then this is again a base. This is also a base tool as well. So the idea is very simple. Base tool is the class, and then you have other classes which are deriving from that. So this is the vector store QA tool. And as I said, we have to give a description on when to use this specific tool, right? We also looked at in the diagram earlier. And this is very good. You define a description. Okay, use this tool to answer questions about ZenML. So I'm basically just telling the LLM here that, okay, this is a tool. It is backed by a vector store. So this is the vector store that is taking as an input to this particular step. And you remember this step is taking this vector store from the previous step, which is the index generator. So ZenML is now responsible for making sure that the output of the previous step somehow makes its way into this step, no matter where this step is running. Maybe the other step was running on a different cloud environment. This is running locally, but ZenML was going to make sure that this thing lands up in your function here. So we take in a vector store and we take in the description, the LLM which needs to be powered by it, and we just supply that as we just define a tool with that name. And what we do is we then define an agent here. So we define an agent from LLM and tools. This is again a helper which is provided by LangChain itself. So you don't have to write the entire logic yourself. And you can just provide in the LLM, you can provide the set of tools which I defined earlier, and some prefix and suffix, like some messages, some initial prompt that you want to give it. So for example, in my case, what I've done is I've defined it in a way that this is where you give the personality to the agent. So this is the prefix which goes into every prompt that you send to the LLM model. So what happens is I'm defining it as a ZenML agent here, and then giving some custom prompt on a lot of other prompts here as well. So that is the idea. So I'm giving that as an input, and then I'm defining the agent executor from these. The agent executor is the orchestrator which takes in the agent and tool and makes the whole orchestra play. That is the idea. So I'm defining that and returning that as the output of this step. So all I'm doing is this simple things. So now what happens is if I run this pipeline, ZenML will go through all of these steps, and as a final step, it will just export this agent executor as an artifact in one of my artifacts store, whichever I have registered there. And that is the idea. So now if I show you 1 second, so I have a test script here. Now maybe I'll show you what the test script looks like. Maybe then we can look into how this actually works. So how you imagine you've run the pipeline once. So you already run the ZenML pipeline using Python run.py. And after doing that, you already have these artifacts stored in your artifact store. And in my case, I'm doing it locally. So my artifact store is just my local machine. So all of these things are stored somewhere in my local machine at some path. So what I do next is I try to get the outputs of these steps. So what I'm doing here is this. I'm using the client, the ZenML client, and I'm calling a function called get pipeline. I'm passing the name of the pipeline, which is something I've defined already. This is the pipeline name. And I'm calling the version here. So this is what makes it really powerful. So let's say whenever I change something in my pipeline code, it registers a new version in ZenML automatically. And I can just choose what version of pipeline to retrieve. So in this case, I'm trying to retrieve version 9. Maybe a previous version was better. So I'll do version 7, version 6, whatever I want that way. And then I get the latest run from that pipeline, and then I get the agent creator step from it. So the last run dot steps is agent creator. I get the agent creator step, and I then extract the details I want from that specific step. That is the idea. And now what we do is I have this breakpoint here. Like right before I call run on this agent user, I have a breakpoint. So what I do is I'll just run this step here. So it will come and stop at this specific point, and then we can start asking questions to the agent executor. But so far, is the flow making sense? Do you have any questions?
Yes.
Or, yeah, go ahead.
Yeah, I think it totally makes sense. The only part which I was very surprised with was the claim that you made, like when one step to the other, like ZenML makes sure that irrespective of whether it's running in local or cloud or whatever, like it makes sure that the first step triggers the next step. I was just like very curious as to how that works behind the scenes.
Yeah.
Is it possible that people are using multiple clouds? Is it possible that people are having that hybrid setup wherein like one step is totally on their local systems and the next step is totally in like maybe Azure OpenAI, things like that. So
Yeah, that is a good question. So what we do, what happens behind the scenes is that, let's say, ZenML works with this concept of stacks. So if I go in
Mhm.
here, if I just straight, let's say ZenML, sorry, my bad, ZenML stack describe. Like, if I do that, the orientation is a bit screwed, but I think it will still give you a good look of it. So right now, my artifact store is a GCP LangChain artifact store, and
Mhm.
my orchestration is default. By default, I mean it's running on my local machine right now. So when I run this happen, the
Okay.
orchestration will happen locally, but the artifact store is a GCP one, which I registered separately. So you can do ZML artifact store, register, and then provide your bucket. So essentially, this
Mhm.
means that maybe 1 second, I'll just also show you just to complete the whole picture. If I do a describe on the artifact, it will show you exactly what the path is for this thing. So what I mean essentially is if I choose an artifact store which is backed by a cloud bucket, let's say this is the cloud bucket which I have, GCGS and // LangChain, which is on GCP right now. So
Mhm.
what this means is that, let's say if I want to, like, ZML itself has access to this bucket. It has the credentials which are already configured and able to access this bucket. Now, let's say one of my steps run on some Kubernetes environment somewhere, and the other step runs on local machine. So the
Mhm.
ZML server, we have a server which powers all of these things. It's an open source server. You can deploy it on your own machine. We have deployed it on our Kubernetes cluster somewhere. Now, what this server does is it knows exactly, okay, this is the artifact store, and it knows, okay, this step is running on this environment, but it needs that specific step. So what we do is we connect that credentials. So essentially, it just boils down to, does this server have access to this resource or not? If you have the credentials, if
Mhm.
you know the path, you can easily retrieve that data from there and then supply it to
And
whatever instance, whatever environment this thing is running on. That's how we
and
communicate.
how are these credentials shared between the
These are,
different steps?
these are shared through this concept called a service connector. So what that
Okay.
means is, like, anybody in your team which has access to these credentials, those can create these things called a service connector. 1 second, I can just give me a sec. What I'll do is I will open up the browser for you because that might give you some idea. So anybody in your team which has access to these credentials,
Mhm.
they can set these up basically. So in this internal server, there's this concept called, this is a service you deploy internally. So there's this concept
Mhm.
called a service connector. This is where it is. So in a service connector, what you can do is you can register a new connector here, and you can see we have multiple connectors here. And when you
Mm.
register a new connector, you can set up the credentials. For example, I want any GCP component to be able, I want to enable ZenML to talk to any GCP component. So I'll just go to
Mm.
GCP service connector. I'll set this up here. So maybe I'll provide in my project ID and I will provide in how I want to authenticate to it. Maybe I have a service account with a service
Mm.
account JSON file which I have, and I can provide that JSON file here, basically service account JSON,
Mm.
and then register it with the server. So now the server has the knowledge of this specific service account and has the ability to assume this role going forward. And now whenever I define any
Awesome.
stack
Yeah.
components in the future, and like they say this is a stack component or whatever, this stack component can be connected with that specific, let's say, service connector. So ZML knows, okay,
Mm.
this stack component needs to be accessed using this service connector. That's how we do it. And not everybody needs to have access to those credentials anyways. Only the person who has access to it can create the connector, and everybody else can just use the connector afterwards. You don't need to see what the
Understood.
credentials are afterwards. So that's how they do it, and it's all open source and available right now.
Awesome. Yeah. This
Okay,
is great.
so yeah, that's really one of my favorite features of ZML is like how people can just run it. Like, basically, I can just run it from here without having to worry about credentials, setting up Docker, setting up 100 different things. I don't even know where this bucket is. Like, this may be some created by some of my teammates. I'm just using it afterwards. So that's how flexible it makes your system. And you can just switch from GCP to Azure in a second. I'll just change the artifact store to some Azure bucket and then this will work all the
Yeah.
same. So that is the idea. So what I'm doing now is this, like, I'm just retrieving the pipeline, latest pipeline, getting the latest step, getting the agent creator from it. And then all of that is just like different things I was trying out. Don't really have to look into it, but you can also go into the GitHub repo later on to figure out how it works.
Mhm.
But essentially the point of the highlight is, like, we are now at this breakpoint. And this agent executor is what we got from the previous pipeline at PageView. From the version 9 of the pipeline, this is something which we got. You know, also choose
Mhm.
other pipelines version, but I have done a lot of different things with different versions, so they're all mostly just foobar right now. But the version 9 is the most stable version right now. So what we do is this: we can take this thing, and
Mhm.
now what I can do is let's send it a prompt. So maybe the first thing I can ask is who are you? Because that would make the most sense. Because I chose to give it a custom prompt with ZenML agents things, right? So I will probably want to ask it, let's say, who are you? And now this agent needs to figure out like what is the action that I want to take. Should I use the vector store right now? Probably not, because it's not asking anything about ZenML, right? It's just asking who are you. So it just gives you a final output like I'm a ZenML agent. It's an operated by ZenML. I perform these things. I can answer questions about ZenML. Let's say if I want something specific about ZenML, like maybe I ask it, what is an orchestrator? Because that's something that we've been talking about so much. What is an
Mhm.
orchestrator in ZenML 44.1? Let's say that's my question. Right? And now when I send this specific query, you can see the action has changed from previous action. So the previous action was a final answer, which just sends you some answer randomly. But this time the action is different. This time the action is ZenML 0.44.1. This is the name of the tool which I supplied to it. So if you go into the tools here, if you go back to the tools, you can remember we supplied this tool here with this name and description here. That was the idea. Now, when asked a question which is relevant to ZenML, it figured out, okay, I don't have to just send out a random human message. I have to use a specific tool. And this is the action. So I'm going to use this tool, which is a vector store. And what input should I give to this tool? This is the input. What is an orchestrator in ZenML? So that is what it does. So now what this does is like if you go through the entire flow here, it will be very clear how this entire thing works. So when you first ask the question, the agent returns a set of, this is the output of the model, by the way. The model will tell the orchestrator that, okay, I need to perform this action with this input. Now the model itself can't do it because the model is sitting in some server somewhere. It can't really perform those actions itself. But the orchestrator here will now see, okay, this is the tool I have to use, and this is the input I have to do. So it makes the call to that tool with this input. And then it gets this output back. This is the observation. And then it sends it back to the model. Now, model has all of the context it needs. The model has the answer right now. The model will now construct this answer and give it to you as a final output here. So this is the final output. And so now once this thought was passed on to the model, then the next action for the model is the final answer because it doesn't need any more information basically. This is a chain of thought which is happening. So the first time it was
Okay,
it was
so
telling the
the
orchestrator.
final answer, does it have like any rewording? Like, is it trying to make it more humane? What does the final answer do?
Yeah, in most cases it does. For example, if it were a huge observation, like if there were many things that must have been a part of the observation, it would have chose to summarize it or some other ways, but you can always control how that works. So it's all
I
flexible in
see.
terms of
Okay.
how you do it. Yeah, but like usually just outputs the same thing. But in terms of the flexibility that you have, you can always define how you do it. So whatever
Okay.
observation comes in, you can choose to maybe just give a one-line output every time.
Okay.
You can
Okay.
imagine that be the case for online Slack bots or online chat bots, the one which pop up on the website. You can't really output like huge paragraphs there. You have to only output one sentence. So you can design your agent in a way that only outputs one final answer, basically. So you can see this was
But then
this.
that
Yeah,
is a
go ahead.
configuration you're saying it doesn't happen at a command level. It's something which we have to configure for the whole of the model. Like we set it up already that any question which the user asks, we will only answer in one line.
No. That the thing is like that doesn't happen on the LLM side at least. That happens
Okay.
on this agent definition side. So to be more
Mm-hmm.
concrete with that, what I mean is, let's say for that we need to go into the like how these agents are defined in LangChain. So if you go into the definitions there, you can see like basically it's a work of the agent executor. So the agent executor has instructions on what to do. So it gets an output
Mm-hmm.
from the LLM. Now it is fetched whatever data it wants and then given it back to the agent again. So now this is where the prompting happens. So in the second step where you take the relevant chunks and you give it to the LLM again. Okay, now this is the context you need. Now construct a human answer. That prompt is what you have to modify. So if you modify that prompt to only include like one sentence and XYZ, then the model will just input one sentence. But it's not definitive, of course. You just there's no switch. There's only a prompt. You're only just telling the thing that okay, just reply in one word. If it doesn't do it, it's up to itself. So like you can't really control what the output should be, but you can only just prompt it to do it the best it can. That's how it is.
I see.
So
Yeah.
everything that you
And
want
we
to
have to we have to give the chat history every time when we are like passing the command because I saw
yes,
the like yeah.
exactly. Yes.
That's
So the chat history thing is optional, of course. You can also
okay.
choose not to pass anything, but that is what enables it to hold conversations. So what I imagine it to
Hmm.
be, why chat history is important in my case is because this chat history thing will be populated by my Slack thread when it is in production. So if I go into
Mm.
my main, if I go into my main file, which is where I deployed into Slack, where is it? One second, one second. Oh, it's in a different branch altogether. Anyways, like I can go there some other time. But maybe what I'll do is let me do if I can go back there. Still the process is running. Fuck no. Sorry. But yeah, the thing is like in the main function where you deploy the Slack bot, that is where you can define like all of these things. So you can choose
Mhm.
to get the chat history from a Slack thread. So whatever active Slack thread there is, you can choose to
Mhm.
send all the messages as a chat history because you can imagine a scenario where let's say if imagine we're on Slack right now and somebody asked a question to this enable bot. Let's say what is an orchestrator, but somebody else also replied there with some other context, but did not tag the bot so much. Maybe they asked, okay, this has changed, this has changed. Like there are five more messages which happened, and then a bot gets triggered afterwards again. So bot still
Mhm.
needs access to the top five messages which happened. Otherwise, it's just out of context right now. So you can't just tag the bot in every message. The bot needs to
Mhm.
be able to read the whole history somehow
Yeah.
and then figure out what the next step should be. That is why chat history is
Yeah.
important. So that's what
Understood.
we do.
Yes. It acts as a session history and it becomes a conversation rather than just a
Exactly,
Q&A.
exactly. It gives you the chance to make the bot more reasonable and more grounded in the terms of how to answer things. You can
Mhm.
also choose not to include it, of course, but that's a different thing altogether. But
And
yeah,
whatever you respond over here, like suppose you're giving the prompts to explain to the bot for suppose that the answer they have given is not correct and it
Mhm.
needs to be modified. Is that something which is consumed for like further ML, or is that something which does not really reflect on the vector data store
Mhm.
we are seeking from right now?
Yeah, in this case, I'm using like a proprietary LLM. So it's like an
Okay.
Azure OpenAI LLM. So I can't really fine tune the model. But the
Okay.
stuff which you're talking about, the feedback stuff, that would work
Ah.
if I had my own model fine tuned. Like if I used an open source model,
Okay.
if I were fine tuning it based on our data, then maybe I could choose a feedback mechanism to like maybe have more high quality data, maybe have better prompt techniques, maybe have good examples to show to the LLM and then have it make it work that way. But if it
Mm-hmm.
chooses to not perform well, I really can't do much instead of just prompt. So
Mm-hmm.
if I go into the prompt here, like if I go into showing you how this prompting happens, you can see I there's always this thing which says like it's constantly learning, improving, capabilities
Yeah.
improving.
Yeah.
It does the best by itself. Like we just try to make it work the best. Like we just try to say that don't answer if you're not sure. Like all of these can just be prompts. Like there can't be
Right.
any proper mathematical or distinctive way you can make it work that way. All you
Mm-hmm.
have is the English language with you basically.
Mm-hmm.
Like
Got
we
it.
just for the Slack which is deployed on our Slack right now, we just have a prompt which says do not answer if you don't know anything. So most of the time it just says I don't know. Then that's fine. It's much better than giving a wrong answer. So
Yeah.
that's how you just make it prompt that way. That's all you can do basically.
Yeah.
But yeah, this is what I want to show you. Like this is how it works. Like if this agent has the capability to choose actions, and you can do it throughout a chain here. So the first action was this vector database. The second action was the final answer. And if it were
Mm-hmm.
like multiple steps, if it want to do like maybe you would have asked it to also perform searches on hotels, also book something, then there would be multiple actions. The first action could have been search for a hotel. Second action could be book a
Mm.
hotel. There will be multiple action, and the final action would be a final answer. So this agent knows exactly how to navigate through these different things because he's applied those tools to it. That is the agent.
Yeah.
Now this is
Awesome.
yeah.
So
So
this is a great, yeah, this is a great demo, Jayesh. So are we looking into some future investments wherein this is going beyond just CLI? Are you folks planning on like some UI experience as well, or it's going to stay CLI?
Yes, I think I mostly just work on the weekends on this project, so I'm not sure. I'm planning to release it on the Slack right now. So there's a Slack bot which is active on the. Like I can show you the link on how to get it. Where is it? Okay, there it is. So this is where you can go into the Slack channel that we have, but I can also go
Mm-hmm.
into the Slack directly to show you. So that is very rudimentary bot. It just answers you questions based on context. Doesn't have anything else. So you
Mm-hmm.
ask something, it
Mm-hmm.
answers something. If you ask it who it is, it doesn't know because it's just a simple chain. It's not an agent. So what I'm doing the next
Mm.
step is I'm trying to deploy it as a Slack bot later on. So the Slack bot will be this agent which can do hundreds of things. In the future, I want it to have also have capabilities like know exactly who to contact to. For example, if a hard question comes up, it doesn't know the answer to it, then an action could be referred to some engineer. And that would mean sending a Discord message on our personal Discord, sending a message about the context and say maybe help this person out. So that way,
Mhm.
like right now, what happens is Slack is a huge problem for us because we are working on our own stuff, and there are like hundreds of messages which come in. Like maybe daily we have
Mhm.
5-10 messages, and now we have to put our energy away from the work into looking at what the each problem is, and then figuring out if we are the best one to answer it. There are some which are very simple to answer, so all of that thing can be handled by the bot now. Like answering basic
Correct. Yeah.
questions and forward complex questions to our Discord right away. So we don't lose context. We just keep working on our stuff, and then at the end we can help with it. So it's like a frontline worker basically, and
Yeah.
that's what we
Yeah.
want this to ultimately get to that stage. And
That
that's what I'm
that's a
working for right
very yeah, that's a very nice visionary goal, I would say. Like I feel like I'm sure thousands of people resonate to the problem statement you said right now. So if the solution just commercializes, I'm sure it's going to be a good hit. But Jayesh, once again, like this demo was really good. There's been extreme amounts of questions flowing in the chat, so I want to
now.
know
It's
if
good.
we can jump to that, or is there something
Yeah,
else
we
left?
can go. But I think I can just show you like the final thing, or we can
Uh-huh.
like this is what the bot looks like. So you have these messages. You can just say, okay, let's say what is the best orchestrator to use, and then it tells you the best orchestrator to use. And this is and that's all of that. This is how it works basically. You just tag the bot,
Mhm.
and then it answers. That's how it is. But yeah, anyway,
Awesome.
let's go to the
Yeah.
questions.
Yeah. Awesome. Cool. So I'm gonna chronologically go because I know we
Mhm.
paused like some time back there. So this question is again from Priyadat, asking what is the runtime latency for fetching the vector stores? So I think
Uh,
again it depends on the data. I think we briefly discussed this, but yeah, I'll let you answer.
Yeah, I think that's the best we can answer to it. Like it's highly variable. It depends on how big your system is, like where you're storing it. Like if you're storing it locally, then it's the retrieval is super fast. If you're storing it some bucket in some other region than you are currently, then it might take a bit longer. But like that's uh, somewhat generic, I think.
Mhm. Mhm. Yeah. Samirit has a question. I think this is probably not redirected to you, but they are having a problem saying Azure version shows me an error saying the Docker container is not compatible with Chroma. Would you be aware of what needs to be done in
Uh,
that case?
Our country is not. I think if you're trying to, the last I checked, Chroma didn't have a Helm chart, but I'm not sure if that is the case anymore. But you can always like run it locally on a like. What I would suggest if you want to use Chroma is just spin up a Docker container and then run it locally there, because it's an open
Mhm.
source app. It runs its own model there, so you need to have sufficient memory on the Docker container at least, and then like I think that should be good enough. Like
Mhm.
if you can run it locally, you can run it on a Docker machine. Obviously, like it's the same environment. Just copy the environment details here and just spin up a VM or some other place where you can run it and then expose it through your Ingress or some other way. Or you can also use V8. It has also Helm chart and it's open source.
Okay. Samirit, I hope that answered. Please feel free to drop a follow-up if needed. Next is by Vivek. Uh, Vivek is asking if the latest version is corrupted, how do you handle this too?
How do I handle the store? Okay, so let's say if the latest version was corrupted, what I would do is I would just switch to an older version. So if you look into this pipeline code which I had, the test one, so that allows you to choose what version of pipeline to get the agent created from. So let's say the first thing I need to do is set up monitoring. Of course, I need to set up um, some kind of validation framework. So right now it doesn't have any validation framework. So there's no person, no software which is testing the outputs of this agent. So usually there are many projects which have come up now which can choose validation and then see if the answer is offensive or not. And in that case, if I figure out it's not right, then I can just roll back the version here. So what I'll do is in my Slack bot, the code would look something similar to this one. I can just choose version 8 instead of the version 9, and then go back to a version which was working previously. And that would be the version corresponding to the previous version while I fix this new version. So like if something fails, you can always roll back or choose between different versions on how to work with it. I think that's how it is. And if a tool is corrupted, like if the tool which answers this question, let's say we have multiple tools for different versions, if a tool is corrupted, you can just remove the tool from the agent's toolkit and then add a new toolkit, and then add a new tool afterwards after you fix the issue. So the example offers you the structure. It tracks everything, it manages everything. You can just switch between different versions very easily. You can also look at the dashboard to see each of these pipelines. So it's super simple afterwards.
Mm. Awesome.
Yeah, but
Yeah, I
question.
think like a small downtime is expected nevertheless because obviously you're switching between the versions, so people will still see the corrupted version for maybe like a few minutes, but that's probably a better bargain than having to like redo the whole thing than just like quickly switch the version and get it up and running again. So
Yes,
yeah,
yes. But
makes
as I
sense.
said, like I think that the most important part is like figuring out if it's wrong or not. Because that
Yeah.
like you can't really have a software to do it. You have to have an LLM again, an LLM vetting an LLM. You have to ask the LLM, okay,
Mhm.
this is offensive or not. So like that's not it's all a
Yeah.
game of probability afterwards. Then.
Yeah, and again, this is coming with a clause that we trust the LLM, which is vetting to not be
Exactly.
corrupted. So
Exactly. So
yeah,
that's just how it is. Like it's just
yeah,
no definitive way to actually do it.
yeah, yeah. Cool. The next one, I think, Mike, this is something I can answer myself. Is this even going to be available for viewing after? Yes, Mike, all the videos that we have, which we do as live streams, are also available as offline. So you already must be seeing in the comment we shared Jayesh's last episode. Similarly, you would be seeing the link for this episode as well available in the Happy Hours playlist. And Parth will probably be dropping the link to all the playlist videos that we have as a part of Happy Hour, so you can watch every other episode as well. So yes, that's a short answer to you. The next one is Nitish. So Nitish is asking, in Hindi language, OpenAI response latency is quite high, which is around 2 to 6 seconds. But in English, the latency is much better. So is there any way to reduce latency and track performance in ZenML?
The thing is, like ZenML itself, it doesn't have a model, right? ZenML is just the framework which is allowing you to design these pipelines, allow automation, allow triggering, allow tracking of artifacts and all the things. So if you're looking for specific performance in Hindi models, I think the best shot would be I don't remember the names off the top of my mind, but there are people who are working on Hindi tokenizers. There are people who are working on Hindi models. Like I think you can best choose them instead of the OpenAI models. You can, but just to give you an idea what those models are, those are just like open source models which are fine tuned on large corpus of Hindi data. That's what it is. And there are many other languages which are also part of it. So I would encourage you to just search for Hindi LLMs, and I think there will be a lot of them which come up. I don't remember the name unfortunately. But like in that case, if you don't find the OpenAI answer satisfactory, you can just go with a different model which is specifically tuned. I think that will have a much better performance, at least in the Hindi language, uh, if you look into it.
Thank you for that, Nitish. I hope that helped. With that, we have exhausted the questions in the chat. We do have all the links shared in the chat as well for today's session, all the CTAs, including the GitHub repo, which Jayesh just showed us the demo for. So feel free to go ahead and try it out. And meanwhile, Jayesh, thank you so much once again for being a part of the happy hours. We are pretty much on time. If you have any closing comments, go for it.
No, I think the only closing comment I would have is, let's say, maybe some words of encouragement about LLMs and this space in general. So if you're feeling that it's a lot to digest and there's overwhelming you, then I think you should go step by step, because that's how I did it as well. And I think what we need coming out of India at this point is new tools, both in terms of developer tools like LangChain. LangChain, as you know, it's not the best of tools. It's like pretty simple to put together and still has a lot of user base. So I think what I would want to say is people to find problems and either build tooling in India which helps solve those problems, or look into applications of these tools into new domains where you can disrupt. Let's say in terms of tax, in terms of healthcare, in terms of, like, there are many new elements which are coming up which are solving mental health problems. There are tools which are solving agricultural based problems. So it is worth to step back from the tech scene and then look at the whole perspective, like agriculture,
Mhm.
healthcare. Like, talk to your friends from different industries and then see what tools are they using. Is there scope for description? Like, can LLM really help? Like, because natural language can go a long way in making the transition into mainstream than compared to the previous technology. So I think I would encourage people to just look into applications, and the second thing is look into the tooling which enables you to develop it, and try to come up with both of these things in this one, because it's a new era right now, and we can capitalize on it really really well. I think we are well poised to do it.
Awesome. That was very inspirational, Jayesh. I actually did not see that coming, but that was a great message, and I hope people who are watching this are also inspired to try out few things. And as you all are well aware, if anyone wants to reach out, Jayesh is available actively on Twitter, and
Yep.
Jayesh's handle is, I forgot again.
That is
Yes, at
Vijay.
the rate WJ. Yes. So feel free to drop him a message, or feel free to drop us from the reactor team a message if you would like to hear more, or you would like to see part 3 of this, if there is something else which you would definitely love to see as a part of the happy hours. So once again, thank you so much everyone for joining the call, and hope you have a great time coding. Have a good day.
Bye bye.